use the summation formulae to show that this is true. We have to determine A and B. Okay, so let's just write down what we've got. R equals 1 to n of 3r squared minus 17r minus 25. I can write that as 3 lots of the summation r equals 1 to n r squared minus 17 r minus 25, just the sum of ones. This one's given in the formula book, 1/6 n plus 1, 2n plus 1. The next one is actually not, so you need to know it. So 70, I would say learn all of them, to be honest. 17 times a half n plus 1. Okay, not too bad. And then minus 25, I'm summing n lots of 1, so it's minus 25n. I can see in the final answer they factorized out an n, so I think that is a good idea to do straight away. Then I'm going to get a half, because it's 3/6, and while I'm at it, I'm going to start multiplying this bracket out. So 2n squared plus n plus 2n, so that's 3n plus 1 minus 17 over 2 n plus 1, so minus 17 over 2n minus 17 over 2, and then minus 25. Okay, that is a good second line. Now I'm going to get n squared plus 3 over 2n plus a half. Right, now I've got 3 over 2n minus 17 over 2n. That's going to become minus 14 over 2n, or minus 7n. So I've dealt with this, this, and this. Then I've got a half minus 17 over 2. That's going to become minus 16 over 2, or minus 8. Then I'm minusing 25, so I'm going to get minus 33. And there we have it. It's in the right form. I suppose we could say that A is 7 and B is 33 if we wanted to, but it is implied by a result. Okay, second part of this question, we're asked to explain why this is true. Now remember, you can't sort of use your summation formula for r here because we're also timesing it by tan 60r. We're working in degrees here. So let's just work out the first few terms and see what happens. That's a good mantra for maths. If you're trying to work out something that looks quite complicated, just start basic and build up. Okay, so we're going to get 1 tan 60, which is equal to root 3. Then it'll be plus 2 tan 120. Actually, that is the same as tan minus 60. It's minus root 3. So this is minus 2 root 3. Then plus 3 tan 180, and that is 0. So we can see in the first three terms, we're going to get a minus root 3. If we keep going, we're then going to get 4 tan. It's going to be 240, which is 60 plus 180, because I'm just adding on an extra 3 lots of 60 to it. And that'll give me 4 root 3. Then it'll be plus 5 tan 120 plus 180, which will give me minus 5 root 3. Then plus 6 tan 180 plus 180, which is again 0. So we can kind of see that it's just going to carry on like this. Every triple will add to minus root 3. We have k triples Therefore, sum is going to equal minus k root 3. That is enough for proof. Now for the finale, we're asked to use our results from A and B to determine any values of n that satisfy this equation. Okay, well, I'm going to start with the left-hand side because it's going to be the sum from r equals 1 to n minus the sum from r equals 1 to 4. And remember, we showed in part A, the first one is n squared minus 7n minus 33. So then the second one, I haven't written all the whole thing down, but yeah, that's what it is. Then I'm going to be minusing 4 lots of 4 squared minus 7 times 4 minus 33. So that will give me n cubed minus 7n squared minus 33n. And then I just need to work out what that right-hand term is. Get minus 180, so it becomes plus 180. Now for the right-hand side, 15 lots of sum from r equals 6 to 3n of tan 60r all squared. Okay, remember we said when it was 1 to 3n, we had minus k lots of root 3. Now, instead of k, I've got n. Now, all I'm missing is the first two triples. Although we've got 1 to 5 missing, remember the sixth one, when r is equal to 6, we got 0. So I can actually change this to a 7. This equals 15. And then I'm going to have, right, it was minus n root 3. I've just replaced k by n, but I'm missing the first two, so it's going to be n minus 2, or minus n minus 2 lots of root 3, all squared. Okay, that's quite subtle, but very important. So then I'm going to get 15 times 3, because I'm squaring the root 3. The minus is going to become positive, and then I've got n minus 2 squared. So that would be 45 n squared minus 4n plus 4, or 45 n squared minus 180n plus 180. Okay, we're ready to solve it. It's actually turned out to just be a cubic equation. It's going to actually simplify even more. So therefore, solve n cubed minus 7n squared, this is the left-hand side, minus 33n plus 180 equals 45n squared minus 180n plus 180. Cancel out these. N cubed minus 52n squared plus 147n is equal to 0. That tries out the n. And then either put the quadratic in your calculator. In fact, you could have put the cubic in your calculator, but it's gonna have to factorize because we know n is a whole number. And 147 is actually 51 times, no, sorry, 49 times 3. It's going to be minus 49 and minus 3 here. So n is going to equal 0, 3, or 49. But let's just look back at the original equation. We require that n is going to be going to have to be bigger than 3. Okay, because if it was, say, oh, sorry, actually, it's got to be bigger than 5, greater or equal to 5. So n greater or equal to 5. So we're going to reject the 0. Okay, it solves the cubic, but not the original summation. Reject the 3. Therefore, n must equal 49. Well done.